While humans continue to seek answers to grand questions about the universe, such as the formation of galaxies or the existence of extraterrestrial life, there exists another world, so small that it cannot be seen with the naked eye, yet it holds deep mysteries that could change the way we understand reality. This is the world of quantum physics, a field that scientists have been exploring for over a century, with each new discovery leaving us more astonished than the last. Quantum physics is a branch of physics that studies the behavior of the tiniest particles, the fundamental components of all matter in the universe. We are talking about things so small that they are almost beyond imagination. Electrons, photons, and other subatomic particles. In this world, nothing is clear and nothing is certain. Reality is not a fixed and measurable thing, but a matrix of possibilities, existing simultaneously and overlapping, only becoming certain when observed. The magic of quantum physics began with one of the most famous experiments in the history of science, Young's double-slit experiment. In this experiment, scientists shot light particles, photons, through a narrow slit and observed them creating dark and light patterns on a screen behind. However, a strange phenomenon occurred when no one was watching. The photons passed through both slits at the same time, creating an interference pattern, something we thought only waves could do. But when an observer appeared to measure, the wave pattern disappeared, and the photons behaved like simple particles, no longer overlapping. A strange transformation. When unobserved, they existed in all possibilities, but once we looked, they became something definite. This world where particles can exist in multiple states at once, where space and time no longer hold the solid meanings we are accustomed to, opens a new door in how we understand the world. What we call reality is in fact just an assumed structure built from probabilities that we have yet to fully comprehend. Quantum physics also introduces another shocking concept: quantum entanglement. This is the phenomenon where particles can become linked, even if they are separated by millions or even billions of light years. These particles can change states instantaneously, regardless of the distance between them, forcing us to question the nature of space and time. Could there be an invisible connection, something beyond our understanding that links everything in the universe? But the most important thing that quantum physics brings us is the question of the nature of reality itself. If the existence of an object is not determined until we observe it, does reality truly exist independently of human perception? Are we living in a universe where everything is merely a possibility yet to take form, only becoming real when we look at it? The answer could be a revolution in human thinking, a world where everything depends on perception, where space, time, and even matter can change, move, and transform in ways we cannot yet imagine. Quantum physics is not just a scientific field, it is a window into a marvelous universe, one full of things that cannot be explained, but still offer hope for those brave enough to dream of endless discovery. Quantum physics not only changes the way we understand the tiny world around us, but also forces us to rethink what we know about the vast universe. Perhaps the reality we are living in is not something fixed, but something dynamic, evolving, and open, waiting for the next discovery.
In the first part of our journey into the strange realm of quantum physics, we touched on the fundamental mysteries that challenge the way we view reality. The idea that particles can exist in multiple states at once, that space and time may not be as solid and unchanging as we think, and that observation itself can alter the very nature of reality. Now, let us delve deeper into how quantum physics, in all its unpredictability, might completely alter the way we perceive the world around us. Imagine, for a moment, a world where nothing is ever truly real until we observe it. This is the central idea behind one of the most mind-bending aspects of quantum physics, the observer effect. According to quantum theory, particles exist in a state of probability, a cloud of possibilities, until they are observed. When we measure them, they collapse into a single state. The famous double-slit experiment demonstrated this perfectly. When particles such as photons or electrons are not observed, they behave like waves, passing through two slits simultaneously and creating an interference pattern. But when observed, they act like particles, and the interference pattern disappears. This paradox forces us to ask, is reality then merely a construct that only becomes tangible when we observe it? What happens when no one is looking? Does the universe go on, continuing in a state of undetermined possibilities until we decide to define it by looking at it? This idea doesn't just shift our understanding of the microcosm, it challenges our very sense of the macrocosm, of everything around us. In the realm of quantum mechanics, nothing is as straightforward as it seems. Take, for example, quantum entanglement. Imagine two particles, separated by vast distances, yet when one is affected in some way, the other responds instantaneously. No matter how far apart these particles are, they are mysteriously connected. This phenomenon, which Einstein famously called spooky action at a distance, suggests that space itself might not be as continuous and separate as we think. It opens up a new way of thinking about the fabric of the universe. Could everything be interconnected in ways that defy our traditional understanding of space and time? But perhaps the most profound implication of quantum physics is how it forces us to reconsider the nature of reality itself. As we explored in the first part, quantum mechanics teaches us that reality is not a fixed, predictable thing. It is a realm of endless possibilities, where events unfold only when observed. This realization could have far-reaching consequences, not just for science, but for our day-to-day lives. What if the universe is not a collection of static, unchanging things, but rather an ongoing process that depends on the presence of an observer? What if the boundaries between the past, present, and future are not as clear as we once thought? In quantum theory, time and space are not absolute. They are malleable, shaped by the very act of observation. This idea challenges the very way we perceive our existence. If reality depends on observation, then how do we know what is truly real? How much of the world around us is shaped by our perceptions, our thoughts, and our consciousness? Are we merely participants in a grand experiment, influencing the very nature of the universe with every thought, every gaze? As we continue to explore the implications of quantum physics, we are confronted with a question that has no easy answer. What is the true nature of reality? The more we learn about quantum mechanics, the more we realize that the universe is far stranger and more complex than we could have ever imagined. The line between the observer and the observed begins to blur, and in this blur lies the key to understanding a reality that is far more mysterious, interconnected, and fluid than we could have ever dreamed. Quantum physics is not just a branch of science. It is a gateway to a new understanding of the world, one that challenges everything we thought we knew about existence. And as we stand on the edge of this quantum frontier, the question remains, will we be able to fully grasp the truth, or will the mystery of quantum reality forever elude us? In this sense, the 4 hours of quantum truth may not refer to a specific span of time, but rather the dawning realization that the universe we thought we knew is only a small fragment of a far grander, more complex reality, a reality that is constantly shifting, changing, and evolving depending on how we look at it. And the more we look, the more we uncover.
Quantum physics has opened up a mysterious and surprising world where phenomena that cannot be explained by classical physics have become fundamental laws. These discoveries not only change the way we understand the microscopic world, but also disrupt humanity's entire perception of reality. From quantum superposition, the observer effect, to quantum entanglement, each concept forces us to reconsider everything we have always believed. One of the most fundamental discoveries in quantum physics is quantum superposition. In the quantum world, a particle can exist in multiple states at once. A perfect example is the double-slit experiment, where when a particle is not observed, it can pass through two slits simultaneously and create an interference pattern, just like a wave. However, when observed, the particle immediately becomes a single particle, and the interference pattern disappears. This is completely contrary to the macroscopic world, where every object can only exist in one state at a given time. This insight raises a big question. If particles can exist in multiple states at once, why don't we perceive these superpositions in the world around us? Is the reality we see really just a single combination of possibilities? Or is it simply a state that is locked in when we observe it? In addition to superposition, another phenomenon that makes us reconsider the nature of reality is the observer effect. According to quantum theory, the behavior of particles changes when we observe them. When no one is watching, particles can exist in an indeterminate state, but once observed, they collapse into a clear, defined state. The double-slit experiment once again demonstrates this effect. When the particles are observed, they become individual particles, no longer showing interference. This leads to a profound question about reality. Is everything around us only real when someone observes it? And when no one is looking, are they just possibilities that haven't yet manifested? Another equally strange concept in quantum physics is quantum entanglement, where two particles can be mysteriously linked no matter how far apart they are. When one particle changes, the other changes immediately, regardless of the distance between them. This phenomenon has raised questions about the nature of space and time. Is space truly an independent entity, or could it be an invisible network where particles can communicate with each other without having to traverse any physical distance? Additionally, Heisenberg's uncertainty principle plays a crucial role in breaking our perception of reality. This principle shows that we cannot simultaneously measure both the position and velocity of a particle with perfect precision. The more we try to measure one quantity, the less precise the other will be. This reveals that not everything in the universe can be measured accurately, and there may be things in this world that we can never fully understand, no matter how hard we try. All of these discoveries lead to an important conclusion. The reality we live in is not a fixed, unchanging thing. It can change depending on how we observe and interact with it. If particles can exist in multiple states at once, if observation can change their behavior, and if space and time are not absolute, then we might be living in a flexible and full of possibilities reality waiting to be shaped by our own perception. Quantum physics is not just a branch of science. It is a new way of looking at the universe, opening up endless possibilities of what we can understand and explore. Its discoveries not only change the way we view the microscopic world, but also force us to question everything we once thought was certain in the world we live in. Quantum physics is a reminder that this universe still holds many unsolved mysteries, and perhaps the answers we seek are far more elusive than we can imagine.
The discoveries in quantum physics have completely changed the way we understand reality and the world around us. Previously, we believed that the universe operated according to clear and certain laws, where everything had a defined position, time passed in a linear fashion, and space was a solid entity. However, quantum physics has shattered these beliefs and raised major questions about the nature of reality and the relationship between us and the universe. Quantum physics shows us that reality is not something fixed and measurable. In the microscopic world of fundamental particles, principles like quantum superposition and the observer effect reveal that particles such as electrons or photons can exist in multiple states at once until we observe them. When not observed, we can only speak of possible probabilities, not certain realities. This makes us rethink how reality is formed. Could we be the creators of reality when we look at it? And is reality just one possibility in a multitude of potential outcomes? Reality is not something eternal. It is an ongoing, ever-changing process. From quantum superposition, where a particle can exist in multiple places at once, to the changes in particle states when we observe them, quantum physics opens up a new way of seeing the world. Reality, as we have understood it for thousands of years, now becomes fluid and changing, not a fixed thing. This not only makes us reconsider classical physical principles, but also overturns our entire understanding of space and time. No longer are there inevitable laws that we trusted in our daily lives. One of the most important discoveries in quantum physics is the observer effect, a phenomenon that shows the presence of an observer can change the behavior of particles. In the double-slit experiment, when no one is watching, the particles behave like waves and create an interference pattern. However, when observed, the particles become individual particles, no longer showing interference. This raises a profound question about reality. Does everything around us only become real when someone observes it? And when no one is looking, is it just a set of possibilities that have not yet manifested? Additionally, quantum entanglement is a concept that makes us rethink both space and time. Particles can affect each other instantaneously, no matter how far apart they are. This leads to a big question. If space and time are not absolute, can we ever truly understand their nature? Could the universe be something other than a place where everything is clearly separated, and instead be a system full of connections where everything can influence one another? These discoveries not only change our perception of microscopic phenomena, but also the very nature of the universe. Reality is no longer a simple material thing that can be observed and measured by our senses or scientific tools. It is a flexible, changing entity that sometimes cannot be defined until we interact with it. This opens up a new horizon of understanding, where every observation and every interaction may create an entirely different universe. Ultimately, the way quantum physics breaks our perception of reality is not something simple. It marks a turning point in humanity's understanding of the world. It makes us realize that perhaps everything we consider obvious is merely the surface of an incredibly complex and mysterious reality. This change is not only about science, but also about our philosophy of life. If reality is not fixed and can change depending on observation, could we be living in a universe where our perception itself contributes to its creation? Quantum physics not only changes how we see the world, but also changes how we understand ourselves in this vast universe.
Quantum physics has opened a new era in understanding the microscopic world and has also sparked a revolution in human perception of reality. Its discoveries not only change how we view the universe, but also have a profound impact on our understanding of ourselves, our relationship with the world around us. Principles such as quantum superposition, the observer effect, and quantum entanglement have led us to a new realization. Reality is not a fixed and unchanging thing, but rather a flexible process that depends on our interaction and observation. Quantum physics not only challenges long-established physical laws, but also opens new doors to understanding the universe, the relationship between space, time, and our existence within it. It helps us recognize that the reality we experience is not just the simple outcome of physical laws, but a dynamic entity, constantly changing, dependent on our observation. The most important lesson that quantum physics offers is a reminder of humility in human perception. Despite significant advances in science, we still understand only a small fraction of an immensely vast and mysterious universe. The new discoveries in quantum physics are not only scientific progress, but also a call for humanity to continue the journey of exploration, reflection, and pushing beyond the limits of our understanding. In this context, quantum physics is not just a branch of science, it is a tool that helps us change how we perceive the world, allowing us to realize that perhaps everything around us is not as simple as we think. The big questions about reality, the relationship between perception and the universe, are still there, and they will continue to be the driving force for us to seek and explore the endless mysteries of the universe.